Okay, I think we're about ready. Hey Teeny, how's it going? I have a confession to make. I whispered Teeny because I hadn't seen him and a few of the other regulars in a couple days, and I was like, did I just say something really stupid, or do something really stupid and just not remember, or do I just generally suck at life? And while the answer to both of those things may be true, it does not seem to be the real reason why there hasn't been a couple regular. Like, it's just how life works, right? It's just the life of us small independent artists. No, just, you know, when you have, like, you know, 15 viewers max, not counting raids, and in general you're averaging around 6 to 10, and most people lurk, right? You miss the chatters, and we just didn't have as many chatters the last few days. We had some, and I appreciate them all. But now that I whispered Teeny and asked him that, he felt obligated to come into the stream today to see how I was doing, which is fair. No, I'm doing pretty good, Teeny. I'm doing pretty good. Yeah, just kind of a stressful day. Yeah, no, it's late for you. You should get some sleep. First week back in school, all that kind of stuff. You should get some sleep. Hey, Dylan and Kyle. I assume I have given you guys have. I mean, I'm not actually worried about you two. I do sometimes. I don't think I've doxed anybody that hasn't already doxed themselves, or I haven't, like, asked. I mean, everybody knows your real names at this point, so I don't know. Maybe that's bad. Is that bad streamer etiquette? It might be. I'm gonna say Kyle with pride. I should, because I actually know what your name is now. It's helpful, and I don't just call you random other names that start with K. Oh, classic. Totally classic. Tech Savvy Travi responded to one of my tweets. I was pretty happy about that. About my linked list tweet. He said he wants to see it, and now I'm guessing he wants, like, a link to the code, and I'm scared. He actually knows Rust. We are back on that thick RingBuffer today. I didn't update my stream description. There's no way, since I'm getting started so late, there's no way I'm going to be able to get to an iterator for a linked list. But I think we can do RingBuffer today. I think we can do it. All right. I guess starting soon is over. So there we go. We've got it all down. We've got a microscopic dog in the background, and we're doing pretty good. What the actual heck? Hold on. What is this about? Weird charge on my American Express card. One moment. Let me find out what's happening here. Live on stream. I think I just read it wrong. It probably wasn't American Express. I don't use it for any large automated payment, so that's why I was confused. Nope, it was not American Express. Okay, we're good. We're good. All right. Sweet. yeah, let's get into it, shall we? Let's see here. Do a little OSS and DSA. Okay, we know how to get to the right file. Source, and what are we doing? We're doing a RingBuffer. Hold on. Got something in my eye. Okay. I think we're good. Okay, sweet. So what the hell happened to the music? Okay, it's just went from a loud song to a quiet song. That's all that it is. A non-volume normalized playlist. I just have it on random. You know how it goes. Okay. So we finished our RingBuffer a couple days ago. Monday, I guess it was. Yesterday, we started making the RingBuffer a little bit more thick. Had that thin interface, and we wanted that thick interface. So we implemented index and index mute, which is pretty sweet. So when we implement index, we get this syntax for free, for those of you who are unfamiliar with Rust. So kind of like you're used to with C, Java, JavaScript, array. Sorry, I cussed. I didn't mean to. At least I didn't say type, you know. You get this special index access syntax on the RingBuffer through implementing index. So that even allows us to do cool things like, even without implementing an iterator, we could write a basic for loop the way that you would in most languages, right? Where I is index. So that's pretty sweet. From implementing index mute, which was pretty simple as well, we get, as you can imagine, index access, but we have a mutable reference, so we can actually update using that index. So then we, just by implementing those two traits, we get this nice ergonomic syntax and a lot more functionality for free, which is pretty nice for just a couple lines of Rust and just 1 or 2 lines of unsafe Rust. That's not so bad. All right. This was just mostly notes while I was implementing that to understand it and make sure I was doing it right. I did get the math right finally in my head of how to calculate the offset. Like, obviously you could do this with a bunch of conditionals and make it ugly, but the basic offset, when you talk about the elements to the public, right? So if a user says, I want RingBuffer, the element at the 0 index of RingBuffer, of course we know in the contiguous memory underneath that may not actually be there. It might not be index 0. It could be, but it's most likely not, right? And so our self.head is our representation of which index in our actual memory buffer head is at. And so if we just add the index the user passes, right, the index of the element to the index of head, and modulo over the capacity, it takes care of all the wrapping for us. So whether it's wrapped, no matter where it's at in our actual RingBuffer, modulo is our friend. So that's kind of a nice little tip, regardless of what language you are implementing this in, on how to get your offset from index. So your offset in your memory buffer from the index on your RingBuffer, if that makes sense. So that's pretty cool. We got that going. So yeah, let's do Iterator. So I believe the trait I want is actually Iterator, if I remember right. Yeah. So the thing is, if we had a stack, not necessarily stack, because you could do a stack with linked list. If our elements were in a contiguous, and this is partly what we went over yesterday, but if our elements were in a contiguous memory block, which they're not necessarily for a RingBuffer, we could just implement deref, and then it would automatically give us a slice back, and that would give us a hell of a lot of functionality. But since we can't do that, we're just going to implement Iterator directly. So I believe we're just going to impl Iterator for RingBuffer T. And then if we go down here, let's see if this works today. It worked yesterday. Takes a while. Okay, here we go. Yeah, we have a type item. We'll get to that in a second. It's not actually going to be T. We're just going to say it's unit for now. That would be a very bad choice in reality, but we'll say that for now. And then let's do another completion, and it should give me the next. Yeah. Okay, cool. Let's see. Next is option self item. Okay, let me think about this. This is the first time I've implemented an iterator manually, so just, you know, just might take me a bit. Might take me a bit to process it all. We'll probably use the vec reference for how to impl this, because it will, it's going to give me a basic structure and understanding without doing the work for me. Oh, right. But we actually didn't have a vec reference. I just remembered that. Yeah, he's a killer. You gotta watch out for him. He's pretty bad. He's resting. He's kind of like a, you know, like you don't want to disturb a sleeping baby. He does this most of the time anyway. But that is, that's Foxy. Foxy. You gonna get up? You show everybody how huge you are? There he is. Huge guy. Yeah. My daughter would love that. It is technically my daughter's dog. No lie. I could pretend that I'm just like the sweetest person in the world and it's my dog. It's not. I mean, it is my dog, right? It's my dog. But we kind of have a love-hate relationship going on. So that's how it goes. He's a sweet dog though. Don't tell my daughter I said that. Yeah, that's right. He is mostly a good dog. Except, you know, he's like Chihuahua-ish. He's a Chihuahua, so you get all the bad. Chihuahuas are kind of, they're from hell. There's a great meme about Chihuahuas being from hell. I'll have to find it. But as far as Chihuahuas go, he's pretty good. he's what they call a deer head Chihuahua, not an apple head, which is more like your standard registered breed Chihuahua. A lot of people think they're like Doxy Chihuahua mixes, but they're kind of their own thing, okay? They're kind of their own thing. All right. Dog talk. Okay. So for something really simple, you could potentially, well, let's read this. Let's read this so I understand how the heck to do this. He's a sweet dog. Nice. Thanks, Kyle. That's good. That's good. I'll probably send that to my daughter later. It advances the iterator and returns the next value. Returns none when iteration is finished. Individual iterator implementations may choose to resume iteration, and so calling next again may or may not eventually start returning some item again at some point. Okay, so say we get an iter on here. Iter.next gives you, okay, right, that's what I figured. It was an option pointer to 1. So it is by reference. That's what I assumed, because it's not consuming your data structure. Okay, cool. I'm probably gonna do this really wrong. Like, I don't know the rusty way to do this necessarily, but we'll just go with it. So in order to kind of work with this, I know like an iterator on, let me think about this. Usually what you do, and the part of the reason why type item is a thing, because you might think, well, why wouldn't type item just be like a T? And part of that is, I believe, usually you have like a item struct that you're going to have in order to make next work. But I think we might need to just look at a reference implementation for next. So let's do that and see how we can translate that to a RingBuffer. Because I'm pretty sure whatever I see is not going to be a RingBuffer. I know Rustonomicon has one for a linked list, but I want to do my own for a linked list, so I don't necessarily want to read it. They also have one for a binary tree, and that one is very complicated, so it's not really going to help us here. Hey, Nightshade dude. No apologies. I'm going to try. We'll see if I can do it. We'll see if I can not apologize for all the things that I feel I should be better at. Yeah. Okay. Let's see. What were we gonna do? Oh yeah. How can I implement? Okay. Let's. Why isn't select all working? What the hell is happening? Does this just not? Why isn't GPT letting me do select all? That is the weirdest thing. That was really weird. There must be some other thing that's hitting. Okay. Skill issue, I'm sure. Yes. Yes. Credibility. It's very important. You gotta prime ChatGPT with box questions. Oh, right. Yeah. Because of my clip. Oh my god. That was such a frustrating moment. I mean, it wasn't really. Like, I kind of knew it was wrong, but I still went with it. And so I didn't look at the code. I tried to implement it with Box, and I'm just like, no, this is not working. And that's when I went back, and that's where that clip came from. I went back and I was like, It's like, it's gotta be lying to me. And sure enough, just totally lying. Okay. Write an example of implementing the trait iterator for a custom type. Okay. For a custom type. Okay. A range. Okay, this looks nice and simple. I like this. Thank you for doing something simple. Okay. So, all right. So maybe we can just do T. Maybe type item in this case is going to be T. I think the problem is I've just been reading a bunch of like advanced Rust stuff that like I have to read 5 times to really get it. And so all their type items are like these structs that are keeping track of like 4 things at once. Okay. Good times. Yeah. And you got a result, and that's because we're here. Okay. Our index trait might actually help with this, which would be pretty cool if we could make that work. So we'll see. Okay, let's see. So we're gonna start with just type item being T, and we are going to, all right, but we have to have some way of iterating. So how does that work? Oh, let's see. They already have a way of tracking where they're at because they already put it in their type. And I'm just trying to think of like how I can track where I'm at for next. I think this is why I usually would have to see. This is even worse. In a way, it's even worse what GPT did to me this time. Let's think about it up here. If I have a pointer, head, tail, cap, length, yeah, none of those are going to help me. So I think I'm going to want my own type. And I believe the way that you do this is we're going to create a struct of, we'll just call it RB iterator of T. And we could do this a few ways. She's not coming for you. I don't think she's coming to get you. That's not for another 40 minutes. Somebody just got home, so he thinks, of course, that it's for him. Foxy, come on. Come on. Just come rest. Come on. Okay. Oh, dear. All right. So let's go with RB iterator T, and then let's see if we can make this work. How does that work, though? Let me think about it. How does it actually work? Oh, is Foxy a lady? He's a little gender fluid, to be honest with you. It's actually a boy, but I don't know. I mean, I get the reference though. Foxy lady. I get it. He's a boy. My daughter usually does pink stuff for him. Like he has a pink collar and stuff. And then, I don't know. He likes to be one of the girls for sure. But, you know, we're pretty flexible in this house. we're pretty flexible. Let's see. I think I need to ask GPT a different question. No. Did you really already break? OBS already broke. You bastard. Alright. Can you show me an implementation with that requires a special, I would call it an intermediate type. But, you know, I don't know if they're going to understand what that means. And yeah, they did not. Okay, so here's a Fibonacci. Like just a Fibonacci sequence to iterate over. But that doesn't... okay. So I know type item is U64. There's just something I'm not fully getting. To generate the next item in the sequence? It does? How? New current self... Oh, okay. There's an intermediate value. But you see, all of these fields are already stored in that struct, and that's not going to work for me. So I feel like I do need to do like something like a current. Let's just try this again. Oh gosh, I have to click on my scenes. It's so annoying. Okay. Let's just keep going, see if I can figure this out. Current is a use size. We'll just do it by index. But then we're gonna need like our actual RingBuffer. I'm trying to think how I want to do this. I'm gonna try just doing this. Doing this raw. But it's not really... I can't give it ownership of the RingBuffer. So how am I going to do that? I mean, maybe I don't need to. Maybe I just need the pointer. And then I just go through and give it... I could do it that way. And then I'd have to keep track of the length. I think that's how Rustonomicon does it, actually. I guess we can look at their... Oh, if I see it for a binary tree, I think it's going to be way too complicated. But then if I see it for a linked list, I'm still planning on doing a linked list. But realistically, I'll probably forget. Well, probably better to actually learn something rather than not. I'm sure I could make this work. I just feel like it's wrong. And then I'm doing something that is like really gross when I could make it a lot simpler. I'm trying to think if there's another type I could look at. Oh, what if it showed me for an array list? Ooh, let's try that. Let's try that in GPT. All right. Can you implement this for an array list? Or maybe I should just give it the type that I want. it implemented for, but this might actually work. Hey Nexus Null, how's it going? Thanks for hopping in. How have you been? Okay, okay. So our type item is still T. If self.data is empty, self.data.remove 0. This feels very wrong. See, then it's using like some very specialized things. Okay, let's try this. Let's try this. You just woke up? Is it morning time where you are? Or were you just napping? I know you can't see my editor, but freaking things. Okay. Here is a basic implementation of a stack. Why isn't copy and paste working? Like, I am so confused right now. Like, my keyboard cut. Like, why isn't it working in the browser to do Command V? Like, was I really hitting the wrong button? Maybe I was hitting the wrong thing. Oh, that's so weird. I don't even know. Okay. Here's a basic stack. Well, it's not really an implementation. Basic stack type. How would you implement Iterator for this? Okay. Okay. Yeah, no. No, that's not how you do it. Oh, gosh. Because then you're actually mutating. See, the thing is that next doesn't take, it does not take a mute self. It takes a and self. So we can't mutate it. How long do I keep the chat history? Like in Twitch? Oh, in GPT. Forever. Is it bad? Is it bad to keep it forever? I don't know. I'm still in the same conversation. So maybe that is not like good GPT practice. I don't know. I probably don't know how to use it well, and I also am not paying for it. You always start a new one? We could try that. I'm just making sure that I'm not wrong. No, you do take a mute self for Iterator. Am I wrong completely on how Iterator works? Does Iterator consume? I thought Iterator did not consume. Right. Okay. Okay. Let's try it in a new one and see. Yeah, I just figured since it was all Rust that maybe it would actually help it. Wait, I'm doing this wrong. It's because I'm so zoomed in. Come on, Mac. You can do this. Let's do new chat. Why am I using my touchpad right now instead of my mouse? Why, guys? Why am I doing this? Oh my god. It's still doing that thing. Is it there? Yeah, it's there. Am I just crazy? No. It really is Maybe it's just my keyboard's wonky right now. Let's just try this. Unplug it. Just plug it back in. Okay. Here is a basic stack in Rust. How could I implement Iterator for this? Okay. I feel like it's going to give me close to the same answer, and I'm probably just dumb. No, there we go. Okay. You guys are right. You guys are good. You guys are very good. Okay. Thank you, chat. This is what I was looking for. But I get confused. Okay, so then you have this pub function iter. Oh, that makes sense. Oh, I'm so dumb. I'm dumb. This is the part that I didn't remember. So, and I'm pretty sure this is right. Pretty sure this is what I've read other places. Is that you implement you implement iterator on this separate type, but you usually get the iter right through this iter method that you call, of course, on your main type. And it was the translation between the two. That's partly what I didn't understand. So here they are just doing their stack T and their current index. And that's basically what I was going to do anyway. And I think we can make that work. Since we have index already implemented, we might even just be able to use that. And then, this is funny. You'll need to write the logic to access elements. I don't know why that's funny to me, but it is. Okay. And then, right, your item is still T, and you impl the iterator for stack iterator. Okay. Okay. I was getting close to that, but I just didn't completely have it down. Okay. So let's go back to code. And we'll go from there. Yeah. It is interesting. Like, that definitely gave me the right answer. Like, we'll just make this bigger. Okay. In general, like, this iterator should be pretty simple, which is partly why I wanted to start with this one. Like, it's not as simple as like the one we just looked at for a stack, but it's pretty simple based on what we've written so far. So it should be okay. And then this, we just do iterator, and we'll just call this the buffer. Rusty is probably like buff. Buff is pretty rusty, actually. So let's just call it a buff. Wow, PagerDuty alert. It's been a while. It's been a while since I've gotten one of those. Classic unimportant page. Okay, sweet. So let's impl this iterator for RingBuffer iterator. We're going to return an option of T. This should be fine. We could store length here, but we should have access to everything that we care about right there. So our current index should start at 0. We'll do that in our iter method on the other one. And let's see. So we should be able to just do a simple like if current is less than buff.length, then we can just yield it. So we should be able to do some buff current. Let's see if that works. That would be really nice. It'd also make me feel like I did this in the right order, which would even be nicer. I mean, obviously you need an accessor before you can really implement an iterator. It's fairly obvious, but it depends on your type. Like, we wouldn't do it the same way for our linked list, obviously. RingBuffer iterator, current use size, buffering buffer, right, else none. Let's see. Does this handle all of our cases? It'd be really funny if it was that simple. Yeah, I mean, it looks pretty good so far. We'll find out. It's pretty funny. That was kind of anticlimactic, right? Okay. Pub function iter, which takes a self and returns. I think we return our actual. I would think we would return our iterator type. So we should return a RingBuffer iterator of t. Obviously GPT told us this, and I already forgot it. So, you know, if I would have looked at the implementation for a linked list, would have it actually mattered? No, probably not. Probably not. Okay. Guess I have to acknowledge this PagerDuty alert, even if it isn't important. Okay. Anybody else? Anybody else have PagerDuty? Fun times. Or do you all just app engineers and you're just like, well, yeah, that makes sense. Yeah, Kyle's actually in the DevOps world, so I would expect that. A lot of app engineers, they're just like, yeah, no, ops takes care of that. We never get paged. Just like, fuck you guys. Fuck you. That's one. I mean, that is my favorite way of not having to deal with a lot of issues, is just not have users. Right? Helps. Fortunately, we have users. Fortunately, that's how I live and get money. Yeah, we have jobs. I know, Teeny, it's okay. Someday you'll have a job too. Once you finish your master's, I think you'll have a job. I would imagine. Okay, unless you're getting your master's in something super random and you just like watching coding streams. Yeah. Crazy concept, having a job. I know. I don't love having a job all the time, but it does help things. It makes me do things that I probably wouldn't do otherwise too, which is sometimes helpful. Yeah. I am scared as to what I might end up doing if I didn't have dependents, but you know, dependents sometimes make the whole money thing a lot more. Oh, was there an ad? What? You guys are getting ads? Oh, it was the pre-roll. It was a pre-roll ad, right? You just joined. That would make sense. That's the only ad I think that runs on this channel, is pre-rolls. Yeah, so far I haven't turned ads on. For better or for worse. Okay. So all we should have to do is create a RingBuffer. I just realized we never actually made a constructor for a RingBuffer. So that is interesting. I wonder though, for a struct, should I even have to make a constructor if it's literally just the struct like this? Like, can I just do this and just be done with it? Wouldn't that be nice? Missing. Oh my god, I'm being dumb. That's literally the type right there. Okay, mismatch type. Yeah, okay. So I don't have to do a new. I don't have to create a constructor. Oh, really? I still get... No, I can't say that actually. If I was on a different medium, I would say I don't get very many ads in certain ways, but I also have a lot of subscriptions, and I also have Prime. So we'll pretend that it's all on the up and up. Okay, so right. This is the part that I don't exactly understand, because I knew this when I was writing it, that this is like a reference to self, and here I'm saying give me the actual buff. And if I do this, I'm pretty sure I'm going to have some lifetime errors, which I don't really want to deal with. But I guess we could say, whoa, I hit end. Nice, love it. We could say that we know that our RingBuffer iterator, like we know our RingBuffer T is not going to be deallocated before this happens. Let me just think about this. Hey, Roasted. What's up? How's it going? I didn't even notice that in GPT. Look at this. How did GPT get around this problem? Right there, baby. Just a little self.clone. Classic. Oh my god. We're not gonna clone. Just a little clone. We're just cloning the whole stack. Just a small one. It's fine. Oh gosh. I know, but we're not going to clone our whole RingBuffer. I mean, first of all, yeah, they're saying you need to add other things, but they also, like, this would require T to be cloned, and they didn't put that in here. GPT, you suck. You suck at this. Yeah, I mean, we shouldn't have to clone our whole stack to iterate. Or should we? Does that make sense? I don't think that makes sense. I should just be able to do all of this by reference. I'm pretty effing sure. Yeah, it is 3.5. I know, I'm cheap. Yeah, it's just no, it's just the first time. It's not terrible, but then I have to, but then you can only iterate over a T that's clone, and that kind of sucks, in my opinion. Yeah, that's kind of crappy. Okay, so how else could we do this then? If we oh yeah, I forgot all the selfs here. Let's just fix this, even though I'm sure I'm going to have to change everything about this. We're still gonna fix it because it'll bother me. This is why in a lot of places they do a different thing. Yeah, I guess I could ask it to do it without clone. I wish there was an easy way to tell that I didn't have to restart OBS and it would just fix the problem of it not, what am I trying to say? I bet iter on slice. I'm going in like 8 directions, sorry, give me a second. Immutable slice iterator, yes. Okay. I feel like an iter on slice would be pretty freaking easy. But let's look at what the source is for iter. By the iter method on slices. Oh, okay. Let's actually look at this first. It just calls iter new self. Okay, well that's not very helpful. I did switch, right? Yeah, okay. So let's look at iter new then. Iter has a pointer. Okay, okay. I'm not surprised. It has a pointer and an end. Okay. Yeah, so basically, I mean, they're still having to do a lifetime param here, which is interesting. And I might have to do that to make sure that the lifetime is correct here. Let's just try our lifetime param on our underlying guy, but I'm pretty sure it's not going to work. Our underlying guy, how do you like that? It's a guy. It's kind of boomer of me to just call everything a guy. Okay, let's see. You know, this little guy right here, we're gonna change it a little bit. We're gonna give it a little lifetime. We're gonna add a lifetime guy to the RingBuffer guy. All right, I'm pretty sure this is not gonna work, but it looks nice. It's a nice idea. Ooh, ooh, maybe this will work. See you, Teeny. Have a good night. Get some rest. All right. Oh, it was the hey guys emo. Okay. Yeah, no, I just assumed it was the dad in me. I was like, you know, Teeny probably should be going to bed soon. Can I do this? No. Wait, no, this, I just need a comma. I'm being dumb. These are just generic parameters. Okay. Impl AT iterator, RingBuffer AT. Okay, I like all this. Cannot find value current in this scope. You might have meant to use the available field self.current. Yes, I did. How did you know? And this is good. Cannot move out of index. Oh, cannot move out of index of RingBuffer T. Oh, right, because index does interesting things. Wait, why doesn't this work? Why doesn't that work? Because I can call it like that lower. I can just do this. Oh, but index actually copies. I forgot about that. Index copies. Okay, just give me a second. I have to think about this. Is that right? Is that what we talked about yesterday? The index actually copies? Let's see. Yeah. I could add copy, but I don't necessarily want to. But we should look at the... is actually syntactic trigger for deref container. I know this, but only when used as an immutable value. If a mutable value is requested, index mute is used instead. This allows nice things such as let value equals v index if the type of value implements copy. Yes. The following example implements index on a read-only. Oh yeah, this stupid example. I hate it. I hate that example. Just because it didn't help me yesterday. Okay. Interesting. Let me just think about this. Do I need to mute? No, I don't need mutable here. But even without, like, index and index mute are separate. And I think partly what's interesting about some of these is even though, let me think. When you use an iterator and you call next, do you own the type? Let's look at the iter implementation for the slice iter. Assuming I can find it. I know I'm still on code, but give me a second. Okay, let's do it an easier way. Let's look for its iterator trait. Traits. Wait, there's not an iterator trait? They just have an n2 iterator? That's different. N2 iterator is where it actually... I'm so annoyed. Okay, I should change the scene. All right, let's keep hacking around. See if we can figure this out. Okay. Oh, there's iterator. Oh my gosh, how did I just miss that? Silly me. Okay, option and a T. That's what I thought. Okay, let's look at that too separately. Okay, we don't care about you anymore. What the hell is this syntax? This is the problem with looking at standard library as like an example, is because they're going to use like random syntax that we don't even have access to. Iterator. Struct iter to const t, at const no mute, sorted by self.as slice is sorted by. I feel like, is that really how they implemented iterator? Because if they did, that's unfortunate. Because it's like way beyond what I can understand, because it's using things like this iterator thing. What is this iterator macro doing? It's when you have generics. Okay. Like the iterator macro. I don't know this one. I guess we might as well look it up. Iterator. Really? Really? Okay. Why don't you have docs for Iterator macro? Did you import it from somewhere, or is it just like everywhere? Okay. You suck. Is it like here? No? Okay. Let's look. Iterator macro docs rust. Well, don't see it. Okay. Does it show up in my editor? Nope. Yeah, I think it's some sort of special internal thing. Problem with standard library. Okay. That's okay. I forgot what my actual point in looking into all this was. I know I had the lifetime thing. Oh, I didn't want to do copy. So what else did I want to do? I think I probably just need to, since I'm already using pointers, I probably just need to keep track of my pointer, to be honest with you. I probably should just do like a pointer offset blah blah blah. And if I have pointer offset, I can satisfy this whole deal. Whether or not that's right, I don't know, but shouldn't be a problem. For the self.puff thing. Yeah, I mean, like, let's just satisfy our curiosity. Oh, I didn't switch back. Hey, Mod Prog, how's it going? Thanks for dropping in. I saw you streamed recently, but you know, it's like you're always streaming at inconvenient times. No, I'm just kidding. I just wasn't able to catch it, so hope it's been going well. Oh, that's right, you're doing a lot of proc macro stuff. That's cool. I haven't touched that yet. Right now I am pretending that I can. No, I don't have to do that because I already said it's tcopy. Okay. All right. So if I say it's for only T's that are copy, then that works. But that kind of sucks because there's not a lot of T's that are copy. So we'll do an actual low-level implementation. It's as it's as if you lived on the other side of the world. Well, it really shows I haven't caught your stream, because then I might actually be able to see an accent. Of course, you could be an expat, but see an accent. Have you guys ever seen an accent before? It's very impressive. It's time for this puppy to eat, so that's why he's being crazy. He hears the Alexa reminder, and then he goes crazy. She's gonna feed you in a second, buddy. I'm sure she's about to feed you. Okay. That reminds me. I need to just double check I don't have any important messages. I'm pretty sure I'm good. Yep. I'm good. Okay, cool. Okay, so cool. We have this. It's declared as private. Yeah, that's not going to work. Okay, so if we wanted to limit our iterator to only T's that are copy, this works. And I might have to change my into iter. Here, let's do this, and let me use my keyboard so I'm a good person. Where's my iter? Okay, it elided those lifetimes for me. I was hoping that it would. It just takes the lifetime of self and elides it into, even though I had to specify it on my RingBuffer type, my RingBuffer iterator, I don't have to specify it in the method. Yay. All right, don't worry, the puppy's eating now. He's very happy. All right. So that's cool, but it's not going to work for most of what we want. So we could do a couple things. We could, I think, without having to keep track of, without putting a pointer into our RingBuffer iterator and a capacity. So we have two options. Let's just write them out. Okay, so we can keep it like it is, and I think I could make it work using pointer offsets. And then I would just basically kind of match what I'm already doing in our index functions. Here, we could do that. That would be fine. The other option, I mean, either way, actually, that's probably what we're gonna do. But it's just a matter of what we like in our struct better. We can either have a pointer. Basically, we would almost have to keep, we'd almost have to track everything. So that's kind of why I'm considering just keeping it the way that it is, because we'd pretty much need a pointer, we'd need a head, and we'd need a length, so we know where we're starting. I mean, I guess our current would actually just be our head. Oh, that's true. So we would actually just need pointer. We'd need our existing pointer. We would need our head, and we would need a length. It's not terrible. The other option is we just keep the underlying buff kind of in there, and we reach into the buffer for all of that information. I think I want to try it that way and see if it works, and if not, we'll go to the other way. Cool. That way, just as an example, the way that I was writing that out, if we were to implement into Iterator, which actually consumes the RingBuffer, so it takes ownership of it, and you can't use the RingBuffer as a RingBuffer anymore. You have to use it as an iterator from then on. We would need to do it that other way. So, as an example, well, I guess you could actually. I wonder if it would let me move it, and I would just do like RingBuffer iterator into iterator as an owned value of RingBuffer, like where you own the RingBuffer, but I don't know if that would work. Let's try to make this work like it is and see if we can get rid of the T copy. For now, we'll just leave T copy there, even though we shouldn't need it. Okay, so we can still say if self.current is less than self.buff.length, and we're just going to keep current as our, oh, hold on. Okay, we're good. We're good. My eyes are itching a lot today for some reason. Does the iter of RingBuffer stop or roll over? I don't know if I know what you mean, Teeny. Like, it'll wrap around. No matter where head and tail is at, it will iter over all of our elements. That's the thing that matters the most. Oh yeah, no, it returns none. Yeah, so the idea is that once you're done, RingBuffer iterator goes away. So it needs to return none. Otherwise, we'll see. Like, for instance, when we do iterator, then we could do something like this for en RingBuffer, and this would automatically call our .iter method that we just did. And so if you do a for n loop and it looped around, you'd have an infinite loop, right? So pretty sure that makes sense. Okay, cool. So let's see, if self.current is less than self.buff.length, I think this is fine. Yeah, it's a great question though. It's a great question. I'm just happy I could actually answer it, you know, right? Y'all done? Okay, bye Emma, see ya. She's leaving, buddy. She's leaving. Yep. She's all done. There you go. Okay. If self.current is less than self.buff.length, then we're definitely gonna have to do something unsafe here in a minute, because we're gonna have to do some adding. I'm thinking I'm actually just gonna do this same offset, which means I probably just want to move the offset calculation to a I probably want to move this offset calculation to a method on my RingBuffer. I'm just trying to think. I think as long as I'm in the same file, if I remember right, I can call a private method, because obviously, like, I don't want to expose that. So let's move this up here. And we will make this a function offset. And offset takes an index, which is a U size, and it returns a U size. Okay. This looks fine. Right, it might help if I actually put a reference to self. That might help. And it's kind of weird to put this above new, so that doesn't make sense. Let's delete that. See if everything's happy. It is. So let's do this and go down here. Whoops, wrong way. And paste there. There. That's not bad. I wonder if I wanted something else besides index out of bounds, but I don't think so. I think that's fine. Because I would want that panic to go up anyway. I guess we can add it as a doc string. Panics if index is out of bounds. Pretty good. Okay. And then in here, we can say, do we just use offset once? I think we do. So these are pretty gnarly though already. But I actually had them on new lines, and Rust format, or cargo format, changed them. Whatever. What, you don't like that? This method takes 1 argument, but 0 arguments were provided. You are correct. You are correct. Okay, that looks fine. So we should be able to do the same thing here. And say offset index. Okay, nice. And then we have our offset for our iterator. Oh dear. Okay. PagerDuty still. I just have to double check that it's very clearly not a real issue. I already know it's not a real issue, otherwise I wouldn't have ignored it for this long, just for the record. Okay, we're good. I feel like I'm gonna write the exact same code as I did for my index functions. And I feel like these index functions had the exact same code already. So in some ways I feel like this should just be an unsafe method on my Beck. I said Beck. RingBuffer. So that's kind of silly. Oh yeah, but one is a ref and one is a mute. But I could make it a little bit different anyway. So let's see. What do you hate about it? Oh, extra bracket doesn't help. What, you don't have an index? No, you don't have an index. You're definitely right about that. Oh yeah, and then it would be self would be buff. Okay. So this would be self.buff. Ooh, this is pretty bad. We'll clean it up in a second. Self.buff, offset index, as ref, expect np how. Yeah. Right. Okay. I know maybe Rust format doesn't want to do this for me, but I'm gonna do it because I can't handle it. Okay. And then what do you hate? Okay, so this is a ref, which should be right. Self.buff, .pointer, as pointer, .add, self.buff, offset, index, as ref. Okay. Ooh, could we actually use... Okay, let's try something else real quick. Come on. Come on, pinkies, you can do this. Let's try a sum self.buff.pointer. So what is this already? It's a non-null t. Expected type parameter t found a reference to t. Okay. Yeah. And then you could dereference the borrow. I could try that. I'm gonna try and add off of the non-null, which is like its own thing. And let's see what that gives me. Okay. Uh-huh. And I'm guessing it's still function add is private. Why does that matter? Consider dereferencing. Okay. Due to the type of the argument passed. I mean, I doubt this will work, but okay. Huh. Well, let's see. Let's see what's happening here. I guess we should get full build output. Might help. Might help us. Wow. Don't know what I was writing those numbers for, but there they are. What? Oh, I'm not in the right directory. That might help. We haven't built today. Not here anyway. Okay. Cannot find value index in this scope. Oh gosh, I did the same thing again. Silly. I'm glad I did that because I wouldn't have seen it. Okay. Error 1. Private method. Interesting. So add is private on non-null? Okay, that's fine. So we do need to do an as pointer. And then we still have something. Okay. So I found a expected type parameter t. Oh yeah, I need the actual, oh my gosh. Oh, I'm silly. I need the actual freaking item. That's the big difference here. Here we actually need to return like the item itself, not a reference to it. I believe that is true. Let's just double check. Like, can we... like on an array, for instance. It's a nice, easy one. Okay. Is there an iterator? Before I switch, I'm just making sure there's an iterator implementation. There's an into iterator, but there's not an iterator. It's probably getting it based on slice. Okay. Well, that doesn't help me. Okay. All right, let me just switch over because I'm here for a while. I'm here for a while. Let's look at it. We have into iterator. We have, let's just look at the vec type signature for it, because maybe I can just say type is a ref to t, like an optional, like I know it's option self item, but maybe I should say that it's an option ref item. Okay, so vec implements, I don't think they implement iterator directly, do they? They do not, right, it's slice. That's why I was looking at slice. Oh my god, sometimes. Okay, and then we were looking at the implementation. So we're just trying to find the actual type signature for next on here. Here we go. Next option and AT. That makes sense to me. Okay. And so let's see if we can make this work. If we go back here and we say instead that our item is actually an auntie, then what happens? Right, lifetime expected. Hey Scott, how's it going? Thanks for hanging out. Okay, this looks better. And that is closer to what we want. We already had our lifetime parameter, so that's not a big deal. Expected reference anti found raw pointer mute t. Okay, that's fine. I should actually be able to use the exact same thing. After I do an add, I should do an asref. And then, but asref actually returns a, I'm forgetting, but it should tell me. Come on, come on. No, you're still on the error. When you actually, oh, is it because I did it on the wrong thing? Yeah, I always do that. That was a me problem. It's supposed to be after this parenthesis. It's because it's off. It's because it's wrapping. It's a little hard to read. Okay. Asref returns an option and a t. Returns none if the pointer is null, or else returns a shared reference to the value wrapped in sum. If the value may be uninitialized, documentation truncated. Okay. So we're pretty darn confident that we don't have a none in this case because we're doing our checks here. But the problem is, like, if we did and we just left and we would return that option, we could potentially be creating undefined behavior and just not really realizing it. So let's just go ahead and rewrap this anyway, and say expect npe how, kind of like we did in our other implementation. Cool. So that type checks. It everything checks at this point. So that's kind of nice. It is almost, it is this exact code up here, except that we added it into this. So that kind of makes me think we might as well abstract that out. And this is very, very close, except we call an as mute. But we could just like get a pointer at that offset. That's another option. It's not terrible. I'm just trying to decide what I want to do with it. I mean, I'm still going to have to do the expects if I do it that way, or we just leave it as it is. It's like not the worst duplication ever. Okay. Cool. Let's just run the tests. Okay. Everything tests out. We didn't write tests for our iterators yet, so, you know, I'm not too surprised. But now I think we can write a test for our iterator. Oh, we can also get rid of this copy. At least we should be able to. If we can't, then we did a lot of work to not be able to get rid of it. Okay, we can. We're good. Sweet. So let's write some iterator tests. Exciting stuff. Maybe we'll do it. Maybe we'll iterate over. We could iterate over a box string. Hey, Vivax, what's up? How you doing? I'm streaming late, so, you know, more chance for Vivax to show up. If anybody's watching and they haven't been following in the past, I have been putting VODs up on YouTube. They're just the raw streams. It has all the music and everything, and that's because of this. I don't have to take the music off my YouTube VODs, which is kind of nice. Of course, you can just watch the VODs on Twitch. They're here for 60 days. They're just on YouTube forever. We are going through a bunch of data structures, and we have been, and we've done quite a bit. If you have any questions about what we've done or you want to see it, let me know. And if you want more of this action, we're supposed to get into trees eventually. I've been making sure that like this RingBuffer is thick at the moment, but then we're gonna get into trees. So feel free to get into my follows. Yeah, that's not how that works, but I'm kind of a boomer, so that's how I'm gonna say it. Am I following a guide or something? Loosely following the Primogens DSA course. Loosely following it. So a lot of these he implemented in the DSA course that he has on Front-End Masters, which you can get to for free. I found out it's really hard from their front page to figure out how to create a free account, but if you Google Front-End Masters trial, then you can get a free account pretty easily. So that's how I did it, because I don't need any of the other Front-End Masters stuff, because, you know, I'm a back-end guy, man. We don't do front-end stuff. So yeah, it was a pretty good course. I went through the majority of it, and I still have a few left in the course that I haven't done yet, but it was a nice refresher on how some of these things work. So I did that a few months ago, and then decided to start trying to implement these in Rust. And Prime was like, implementing these in Rust is the job of a masochist or something close to that. I think he just said you'd have to be crazy, and that's why we're here, to be crazy. So yeah. Oh, you got a new domain, Vivax? That's cool for your project. What is the site about? If it's programming related, feel free to drop a link. Cool. What are we doing? We're writing tests. Let's just create a new one. Let's just create a new test. Iter tests. So at iterate, we shouldn't actually need our RingBuffer to be mutable. What sort of type do we feel like? What, do we want to be crazy? Do we want to be crazy and do like a float? I've never actually messed with floats in Rust. It's not floats. Is it just float? I don't remember. Is it scalar? Like, do I have to like, no, that doesn't make sense. What is a float type in Rust? I don't even know. It is fxx. Okay. So it is like a scalar value, right? Like, can I do an f size? Does that make sense? Is that a real thing? I don't think it is. F64 is default. Okay. I just like size, okay? I just like to put size on there. It makes me feel cool. Well, I don't know why I did that. None of this, well, not none of this, but that was definitely not correct. I don't know what I'm doing. Okay. Clearly don't know what I'm doing. Okay, we haven't done any... What, because I didn't call new? Come on. Can't you just infer that I meant new? What the heck? Yeah, 5 is our capacity, Allison. So ring buffer is a fixed size, so we passed 5 as our capacity. Well, at least this ring buffer is. I mean, most ring buffers are, as far as I know, except the ring buffer that the standard library gives you, which is VecDQ, a growable ring buffer, which I did not feel like implementing at this time. I guess it wouldn't be like that complicated, but that is some much larger mem copies and a little bit more complication than I wanted to. Especially because I'm just trying to solidify ring buffers in my head and how they work, right? Okay, so I should be able to just give it some literal floats, I imagine. Oh yeah, I do a unimute in order to even add values. That might help. Don't mind me. Whoa. How did I not remember that? Oh my gosh. It makes complete sense, but I literally never thought about the fact that you can pass a number to paste in Vim. I mean, this is Emacs, but you know, Vim motions. I never even thought about that. I know you can pass a number to basically anything, right? Any verb, but like, I never thought of it. And so I would have just pasted this 5 times just for the hell of it. Okay. There's our 5. Let's say a little R.8.2, a little R.2. It's because I'm pressing OR to replace. Nice brain. 9.1. Let's go 6.3 and 1. Something cool. Yeah, so cool. All right. So what we should see here is that we can now do a for E and R, and you can kind of see what happens right there. I think this will work. I don't have to implement into Iterator for this, do I? That would be confusing to me. Okay, we'll just keep going. We'll pretend this is gonna work. And then let's just print line E. And I guess as our test, let's just do an I. It's a little silly. It's a silly test, but I just want to play around with some different looping constructs. I++, that's not really, just kidding. I equals I plus 1. And I equals 0. Okay. No, actually I want I equals 1. I want I equals 1. Oh yeah, I knew I was doing this the long way. I know. I was fighting plus equals syntax for a while just because it reminded me too much of JavaScript and Java, but here we are. Oh right, I forgot about this. Let's just do this. And I think I left T as being debug still. Do I still have T as debug? I don't think I did actually. So it's going to complain that T's not debug. But, oh, it knows the type. It knows the type, so it's fine with it, right? Since it knows my type is F64, F64 implements debug, or is debug, we're okay. Now, it might be saying RingBuffer is not an iterator. Okay. Now, can I just say r.iter like this? Ooh, that's the right type. That's the right type. That's what I was supposed to do. Okay. And then our silly assert is going to be an eq of I and r dot length, which I should call r dot len to be rusty, but let's see if this passes. Or if I have a infinite loop. Kind of feeling the infinite loop right now. Because this isn't stopping. Oh gosh. I mean, at some point it should stop. I mean, I've had infinite loops before and the test is just like Stack Overflow. Really? You're still pretending like you're gonna be able to do this? Oh man, that's funny. I feel like it's mostly happened when I've run the tests in Emacs versus the other one. So let's just try it here, because I'm pretty sure this told me that it's a Stack Overflow, like within a few seconds. The assert macro doesn't use a equals when it totally could as a macro. Yeah, it's fair. Nope. Okay, I'd say there's something wrong. I would say there's something wrong. I haven't tried next test, Vivex. But let's just add our debug into our iterator. And we're just going to add a t debug here. And then we won't... have you tried... Yeah, I have not tried doing the correct thing yet, Nightshade. I'm still working on it. Thanks for the high def kappa. Still working on doing the right thing. Let's see. What do we want to do? Let's just debug self.current, maybe. And then actually I just want to, I should keep that, the debug at the bottom here. Because now we're going to do a no capture test and hopefully we'll get it in real time. Love it. Love it. So what are we printing? What are we even printing? We're printing head? And we're never moving. Oh my god. Okay. Maybe I was being a little dramatic, but it's just such a simple thing. It's so simple. And I just can't believe that I forgot it. Unbelievable. Unbelievable. It's totally believable. Who am I kidding? This is very on brand for me. Very on brand. Okay. Yeah, you know. If you're iterating over things, it might help, just maybe, if you did a little bit of this. That might help a little bit. Oh my gosh. Okay. Test result failed. That's fine with me. RingBuffer tests, Iter tests. Okay. So they failed. That's okay. I don't mind them failing. Let's just get the output from that one test. So we just say cargo test, iter tests. Okay, nice. I probably just was being silly here. 1, 2, 3, 4, 5. We start at 1. Oh yeah, no, I was being dumb. I was being dumb here too. We should start at 0. Because then the iter runs 5 times. And then it should be there. So just a bad test. Yay! Yay, we did it. Yeah, we'll just change I. Yeah. Hey, that's pretty cool. So one of the nice things about Iter is that Iter already, like getting an iterator, obviously we can do iteration. That's easy. We can do a lot more than that as well. Now here we've already consumed our iter. Now we can create a new iter. It's all fine because the iterator trait doesn't consume our vec. God, I keep saying vec. Doesn't consume our data structure. So we can just keep going, and we'll just do a new iter just for the hell of it. And let's just say let mute. Do I need it to be mute? No, I don't think I do. I don't remember, but we'll find out. Okay, so let iter equals r dot iter. Okay, so then we have our RingBuffer iterator, which is fine. And then on our iter, we can do things like saying, I don't remember what type this actually gives us, so let's find out. Iter.nth 4. In this case, that should give us our tail. And what is it? It's an option? Yeah, that makes sense. And then give me a second here. I'm getting there. Our fourth element, which should be our tail, which is the first element that we did. So our assert should be sum 5.5. And it doesn't like me already because option float, option, and F64. Okay. Right. It gives me a reference. That makes sense, right? Still no? Still no? Cannot borrow as mutable. Okay. Right, so you do need it to be mutable, which probably means, so that's telling me the nth probably consumes, does it? So, oh, it might help if I, why are you taking this so long to build? There's like five files in this project. I think we screwed it up a little bit. We'll just redo it. Okay, good. Okay. But it actually gave me some 1.5436. Interesting. Ooh. Okay. Let's see. Did our iter work the right way? That's the next thing to find out. 6.3, 9.1, 8.2, 5.5. Why is it reading it that way? Why is 1.5436? Oh. It's real bad. It's real bad. Yeah. Another classic. Another classic. Okay. Nice. And let's just run this with the debug print on just to make sure we're seeing some nice things. Okay. We've got 1.5436, 6.3, 9.1, 8.2, 5.5. Very cool. So we can do that. Another thing we can do is we can do a reverse. So we could say sum, and what was the last thing? I guess it's the same, 5.5. iter.reverse.nth 0. Now this might consume, so it might not work on the same thing, but this should tell us, yeah. Oh really, you can't reverse on a normal iterator? I thought that was part of the thing. You guys are making me sad. I thought I could reverse. Oh, you can reverse, it's just called rev. We just don't like to say the full words in Rest. Oh, it still says it's bad. There's something bad. Oh, you have to implement double-ended iterator. That makes sense. So I'd actually have to implement it. That's cool. We could do that. But honestly, like for a RingBuffer, there's probably not much of a reason to do that, in my opinion. But what else can we do? Let's just say here we'll do this. Let's switch to browser. Just to show the beauty of implementing Iterator. And you suddenly have all the nice functional things that you would expect you could have. So it's pretty freaking cool. Traits are amazing, Vivex, no doubt. Implementing index and then implementing this, it's just like, ooh, you can just create these custom types in Rust, and you can actually have ergonomic syntax around them, and you get a hell of a lot for free. So yeah, now we can map over it. We can do all sorts of things, right? We could do a fold. So we could do important, like oh right, yeah. No, that's a great point. Yeah, if you knew if you had a more optimized way of doing these things, then you could make it work differently, right? Yeah, very cool. So I don't know what else to say. I think it's pretty awesome. I'm on a really fast. I'm kind of like one of those rapid coder people, and as you can tell, I do things really fast, and that's why in general my pace is about 1 trait for every 2 hours. So at that pace, you know, we would have a fully realized data structure in you know, less than 20 streams. Yeah, that's true. Oh yeah, then I can sort, right? Sort is so cool. Like, isn't it just sort? And then I get all the good stuff? Does this work? No? What is it called? I don't know all the things. I should know. I was just looking at it. I know I can do eq. Do I have to do something special for sort? Is that what I'm wrong about, or am I just like forgetting how this works? Why is sort not here? Vivx, help me. Why do I think sort should be on here, but it's not? Is it really just not here? No, it's just comp. That's why I was thinking it gave me sort. Is because it gives me comp. I keep saying, oh, look, I can do this, and then it doesn't work. Hilarious. All right. So good. So good. Okay. Well, what I can do... We'll see if this actually works. Okay, I can reduce. All right. I can reduce. Can I just add plus as a function? Does that not work? That's sad. I wish that would work. I love Haskell. I love me some Haskell. Does plus not work for this? Expected and F64, found F64. Why did you expect this? Do I have to deref in order to add? Is that what it's saying? Probably. Yeah, I love defining my own operators and stuff. Why can't I just do a redo? Everything I keep trying. Look how cool iterators are. And then I try everything and it just doesn't work. Classic. Classic me. Bummer. Okay. What am I missing here? Let's run a cargo test. See what it tells me to do. Oh, right. Unless I provide it. Right, that's reduced. So if I want it to be different, I could use a fold. And then a fold allows me to do an init. Yeah, that makes sense. Okay. So I know I have to change the 0 to an F0 probably. How do you do it? Is it 0? Is it add after or before? I never remember. For some reason I thought this worked. Or do I just need to say the whole F64? Oh my gosh. Am I just getting my arguments mixed up? Probably. Yeah, I think that's what I did. Yep, and it comes first. That was my problem. I could have just looked at my LSP. It literally said init above, like first, and then sometimes. Okay, yeah, I get that. And now, can't I do that? This? No. How do you get a 0 as a float? Why don't I know this? I could do 0.0, but isn't there a way to do that? F0F? No. 0F64. Yeah, it works. It works like right there. Why can't I do that right here? Why didn't it work before? What did I do differently? Yeah, that's valid. Very cool. Okay. What, adding the 0f64? Yeah, I mean, it's fair. Maybe it's ugly. I don't know. I mean, it's probably easier to understand as this, right? Like, probably easier to understand. I just wanted to see if it would work because I haven't really had to do that yet, where I actually annotate a 0. We're gonna go back to 0f64, so I look like I really know what's happening, even though this is a pointless test. Poor Vivax. All right. No, it failed. Iter.fold is greater than 0.64. Why isn't that true? Oh, it's because I already consumed it all, I bet. I bet that's why. It didn't actually even iterate anymore. Is that why? I think that's why. It's funny. Is there... How do I get the remaining size of my iter? Oh, that's right. That's a different thing that I would have to... Right, it's a size hint thing. But don't I have to implement that? Oh, I can just do iter.count. It takes ownership of the receiver self, which moves. Oh, okay. That's okay. Let's just do it anyway. It's fine. I actually just want to know. We'll just do assert false to make it print out. It's my hack for not having to do no capture, not having to move over to my terminal. Iter.count equals 0. Okay, that's what I was thinking. It's because nth actually consumes. And I could have, I mean, I assumed because it took a mutable that it did consume, but that's why that's not working. So we could just get a new iter if we wanted to. We can just create iter after iter after iter. Cool. I'm happy with that. I think that's fun. It was not that hard, of course, but it was a great intro to iterators, and you know, not too complicated. I don't know if this is going to pass a code review, if there was such a thing, but it compiles. It's not too insane. We're just grabbing the pointer on the inside. Awesome. I think I'm done for today. I don't stream on Thursdays. I should be able to stream on Friday. Friday is always an iffy day. I'll definitely be streaming on Sunday. I say definitely, but you know, that's the general schedule. You're uneasy with the unsafe use? Yeah. I mean, I don't know how I would do this without unsafe. I mean, because I have a raw memory buffer underneath. I do not have safe operations for these. The main reason, so I could so I started, I don't think you were here when I started with this, but like I implemented You mean why not do that? I thought I could do that. So I implemented index, which of course I needed to use unsafe to do the pointers. And then I tried just using the index access the same way. So no, I already tried that. It didn't like it. It didn't type check. It wouldn't let me do it. Yeah. Yeah, you want to see it? Let's show you. I mean, maybe I did something wrong. That's always possible, right? But yeah, if I do like some, let me think about it. Self.buff current, I believe would be the correct thing. And then, yeah, it says expected a reference, but of course index gives me the actual thing. But what should I, like, can I just do as ref? No. Should I do an and? Ampersand? How does that work for lifetimes? How does that work? Is it because I already have the lifetime annotator? Is that why it's okay? Oh, I didn't even think about that. I didn't think about the fact that since I already have the lifetime annotation, that it already knows that T lives long enough. I'm so used to saying, oh, I created this reference in this function and it doesn't live long enough. But I already went through the pain of adding lifetime annotations. Oh my goodness. Oh my goodness. That's hilarious. That is a lot nicer, is it not? I keep hitting P because it's Emacs previous line. Good call, Vivax. Good call. The trick is you aren't returning a reference to a value in the function, but to an argument to the function. Right. Definitely. Yeah, so it would... Okay, so let me just talk this out and see if people agree with me. So, for instance, if next was on my RingBuffer implementation, which obviously doesn't work, but just as an example, if this method was on my RingBuffer annotation, I'm just talking about it abstractly, the lifetime gets elided for me. But the main reason I needed the lifetime for my RingBuffer iterator is because RingBuffer iterator has to know how long the reference to its field buff is going to live. So even though, so let's see. So the reason this, so even if I had a more simple data structure and I didn't need the lifetime here, the lifetime specified here actually has nothing to do with the fact that this works, because the lifetime is elided from the input, because what I'm returning is owned by the input, and so the lifetime's elided for me. That makes sense. I was thinking it was because I specified the lifetime already, but that's really just to satisfy the RingBuffer iterator type not to satisfy my next method on the RingBuffer iterator type. Yeah. Yeah, I tried. Okay, I tried. I just didn't think it was going to work. So, I mean, I started with this implementation and it gave me that. And then it was like, okay, it doesn't give me the right type. And I didn't think through the fact that I could have just done this. But I think that's also like a key in my head, that like my intuition about lifetimes is not solidified. And so I should probably try it even if I don't think it's going to work. And then let the compiler tell me that, yeah, you actually do need a lifetime there, or your lifetime is wrong. It is weird. It is weird. It is how it works though. And it's actually explained in the index documentation as well. Right, exactly. Container index is syntactic sugar for deref container.index index. Yep, exactly. So that did throw me off when I did my index implementation yesterday. And so like I wrote my test wrong because I wasn't expecting it to be the actual value. I was expecting it to be a reference. But cool. Hey, we got a code review, you know? We got a code review. All right. RingBuffer. Iterator. I don't think there's any more traits that we need to implement on RingBuffer. I did want to implement an iterator for my linked list. I'm not sure if I want to do that next or if I want to go into trees next. So next stream, we'll either do an iterator for our linked list, or we will start on trees. So that's the plan. Again, thanks for... I got a nice debug implementation. What, on my RingBuffer? No, I didn't bother doing that. No, that's reasonable. I could implement debug. That's a very kind thing to do, right? I have a derive, which of course doesn't do what you just said. But yeah, implementing debug for most of the things would actually be a nice thing to do. It would not be hard for this one, but yeah, I don't want to do a macro. Good suggestions though. The debug one I really like. It's a great idea though. When I do want to do macros, those are great things. Yeah, there's plenty that I could go deep with. I would rather right now, I think, continue to go wide. And like I don't want to skip over important parts that would help me learn a lot, but it's kind of like just as an example, let's see, what time is it? 6 p.m. already? Okay, I should probably go, but I have a method here, you know? We're going through it in a certain way. We start with a really naive array list. It doesn't have very much. It's not very rusty, you know? It's just an array list. We went on to a stack. We didn't do a lot for our stack. We didn't even implement an accessor for our stack. But we learned how to use unsafe mostly well. We didn't have any memory leaks. It looks pretty good. A little bit more rusty in some ways, but mostly just using unsafe. What do we do after that? We did a linked list. We did a singly linked list. Learned a lot about box. We implemented, again, a pretty thin interface. We did a get, not rusty, especially the way I did it. It should have just been an iterator implementation or something along those lines. Not rusty at all. But it was just kind of quick and dirty, get it done. And for the most part, on my linked list, you can push front, you can use it as a very simple stack, right? Very cool. Then we get into doubly linked list. We learned a lot about RC and ref cell. I did write a basic debug implementation, but that was actually just, it's not like an excellent one, but it was just so that I could debug printed at all. And you know, you can kind of only debug print one side at a time because it's recursive. Don't make fun of my code, Vivex. I know you're trying to help, but you know, I'm not saying it's all idiomatic, but like, you know, I think this is pretty good. I'm proud of what I've done. I'm happy with it. I'm not saying this is like I know everything about Rust, but oh, you mean like using the formatter that you get it? Yeah, I'm sure it does. I don't know. I haven't used a lot of it. There's a lot that you can get into. Here's the thing, like, you can know everything there is about a language, and that's cool. That can really serve people. Some people really enjoy that. A lot of people that are really successful don't know everything about a language, right? They learn it as they go along. But, you know, it all depends. All depends on what you're trying to accomplish. For me, I'm just trying to get the basics down, kind of getting data structures drilled into my head, and learning a lot about the language. So yeah. Like, since I'll just say this, Vivex. Since tone doesn't translate, like, you've been around here, I really do appreciate you. I want you to stick around. Since tone doesn't translate, sometimes the things that you say sound really harsh. I'll just say that. And that's okay. Like, I get it. I don't always do the right thing. My code might suck in some ways. But, like, you got to understand what we're trying to accomplish here. That's all. You just got to understand this is, you know, there's a difference between doing everything perfectly and then just like going through a process of accomplishing things and learning things. That's all I'm saying. No, it's cool. It's cool. I have, for the most part, not taken what you said that way. I just had to say it out loud. Like, I'm not like upset at you, or, well, that'd be really dumb if I was upset at you, but I'm not upset at all. I'm just explaining, you know, just like, I want to make sure we create the positive environment for learning here, for other people, for myself. I have to maintain that environment for myself, so I don't feel like shit, right? It's important. No, but you're good. You're good. Yeah, so, like, I really appreciate your input. Don't get me wrong. Yeah, so this was just a quick and dirty, like, I needed to print this because there was a bug and I couldn't figure out where it was at. So we just printed the whole thing, and it was ugly as sin, no doubt. I actually kind of like sin a little bit, you know, post church person myself, but, you know, outside of that. Okay. So this was our linked list. We learned a lot about RC ref cell. We made it a little bit more rusty. We used I mean, using RC and ref cell, you're already pretty rusty at that point, right? I mean, you also can't do it without something that gives you the option of having multiple pointers. You know, we get a pushback, we get a pop front. Again, it's kind of a thin interface. I didn't implement any traits, but the main point of this is we got a doubly linked list. We learned RC ref cell. And then what did we do? We used it as a queue. Again, the queue, pretty basic, pretty simple, Q, DQ, and peak. And that's all that we did. It's kind of ugly. The get is already really ugly. The peak extends that ugliness a little bit. That's okay. And then we got into where we are now, which is our RingBuffer. And yeah, I think this was like actually implementing the RingBuffer wasn't that hard based on what we've already done. And so it was a lot easier to go from, you know, getting the RingBuffer implemented. Wasn't that hard. It took me a while, right? If you were here, it took me a while, but it wasn't that hard. And then we get to like drill into some of these traits, and that's pretty cool. I think what I want to do is, like I said, kind of continue to go wide, and then as I feel like I need to understand something better, we can implement some of these extra traits and do some of the fun stuff like Vivek was talking about. That's kind of what I'm down for. So anyway, that's it. You made me do a tour again, which is good. It's good for me to remind myself of what we've gone through so far. So very cool. Thanks so much for hanging out. Thanks for being here. We'll be back in a few days. Let's see if anybody's streaming that we know. I don't really know Acorn, but she is streaming. Let's see if there's any rusty people streaming. Let's see. The danger of showing you my Twitch homepage. We'll go here. Let's do Rust. Just me. Lonely Rust developer. Cool. Let's go and go ahead and we'll raid Acorn. I've never raided her before that I remember. Cool. And we'll catch you guys next time.